Hello everybody, Edgar Fernandez from Pharma-CHEMICALSAFETY located in Brantford, Ontario. This is the second video of the combustible powder video series. So the topic today is the classification and parameters of combustible powders. Our mission in the company is to help you to protect people's lives by reducing incidents drastically through my sufficient methodology, and this part of the videos is part of this methodology. We have 23 years of experience in process safety and occupational safety areas in pharmaceutical, manufacturing, oil and gas industries. Currently hold a professional engineer designation in the provinces of Ontario and Alberta, Canada, and I hold the CRSP in Canada and the CSP in the United States. I'm a chemical engineer. So the video today, we're gonna see different parameters of the combustible powders, what we need to measure or what data we need to get in order to have a better design of our process that they are involved with combustible powders. How we're gonna design and build explosion venting proofs, for example. How we're gonna design our process in case of we need to empty super sacks or sacks of combustible powder to a mixer tank, for example. What are those parameters that are important? But the first thing that we need to know is if we do have combustible powders. If we are getting combustible powders as part of the raw material, or we are generating combustible powder as a part of the process. Remember on the last video, on the first video of this series, we have that process that you can have raw materials and also you can generate dust due to grinding, polishing, blasting, those type of operations. They can generate combustible powder. But there are three steps actually that we need to do. The first one is we need to take around 1 kilogram sample of the powder combustible dust that operation is generating. Normally that's the standard that the certified laboratories they ask you to get. Some of them they ask 2 kilograms because depending on what what test you're gonna get, what data you want to get from them. So that's the amount of material that they need to conduct the different tests. The second is you need to send the sample to the lab, and after you need to ask to conduct a go no go test. So that's the name of the test that pretty much is gonna tell them if the combustible powder if the powder is combustible or not. That's the only thing that this test is gonna tell you. They follow different standards, the ISTM. There are different standards of how to test combustible powders depending on the different parameters. So the first thing is you need to know how to if your material is combustible or not. Now there are other ways to get that data. We are not without sending the samples to the certified lab. And you can talk to the vendor in case of you are getting raw material, because the vendor they test their finished goods as a part of the GHS regulation. Now, when it's in Canada, you stored these super sacks with material on, before transporting, so you are regulated under WMIS, and so they conduct this type of test. But maybe you're gonna see some difficulties to get that test from them because they don't know how you're gonna use that material. But if you talk to them and you explain them how you're gonna use the material, they're gonna collaborate with you, and then they're gonna give you a number depending on what type of process you have and the parameter you are looking for mainly. Before some companies, some specialists, they were using a worldwide database to that this database they have the different parameters of each material regarding on this topic, combustible dust. But NFPA and OSHA, they don't allow that, to do that anymore, and that's okay. And actually, that's perfect because The database, in my experience, I found that the database and the results from the lab, the gap was so big. So there is a big gap. So that's I don't recommend to use a database, and actually you cannot use it by regulation anymore. So you have two ways. One, you talk to the vendor, or the best way is you go and you send the sample to a certified laboratory. So these tests they called a screening test as well. So determines where a powder or dust will explode when exposed to a source, ignition source, when it's in form of dust or a powder of a dust cloud. Um, the test result in a material being classified as either of the type go explosive or type no go non-explosive. That's like I said, that's the test. That's gonna the result of the test. So it's explosive or not. So another name, as I said, is the go no go test. And pretty much that's the test is due. Some of the labs they offer a certain package for depending of the parameters that you want to get from them, and they have different names. I won't mention the names on the labs. You want me mention that on the comment section. I don't want to provide many of them. There are all of them good, but it's up. I mean, talk to them. It's up to you as a specialist or as a process safety engineer which one you're gonna get. Um, so for me, all of them they are good. They are very professionals. And they can help you actually to understand better the test that they do. On these seminars, on this series of seminar videos that I'm gonna post in my channel, I won't talk about the test because that each one of them they have standards and they are very extensive. So I'm gonna let the specialists to do that, those labs, because they have way better, not understand, but very better qualifications to do that, to explain that to each one of those STM standards. So that's a lab test, how they produce those type of results. But for sure, you need to use one of them. Once you have the results from the no go for the go and no go test, or from the screening test, that your material is explosive. So now you need to get the classification of it. And how you gonna get it? Well, there are two parameters actually. Well, it's one actually that is gonna give you the classification. And one it's the KST and Pmax. KST is the measure the speed of the dust cloud explosion, so how fast it's gonna travel. And the Pmax is how the measures of the maximum pressure of the dust cloud explosion. So it's gonna give you how the pressure that it's gonna generate and the speed that pressure is gonna travel, that explosion is gonna travel. And that's very important, especially the KST, because that number is gonna give you the value. It's gonna give you that value, and it's gonna tell you what type of dose you have. And on the next slide, we wanna talk about it. So the KST value that is measured in bars per minute per second. That is how the velocity of the explosion. So it's gonna help you to classify the dust or the powder according to NFPA 654. And it's very important to get this value to design better your process, especially when the process includes dust collectors or explosion venting proof panels, for example. So the engineer or the engineer firm who's designing that, he's gonna ask, or they're gonna ask for these values. You have there are ways on the NX6, on the NFPA 654, NFPA 68, or inclusive 69 that they need to use to design this type of equipment. So the classification it goes from ST0, that is 0 bars per minute per second, and one of the materials that you can find under this classification is silica. You have ST1, that is any value above 0 up to 200 KST. You have, and then the examples of this one can be on the food industry, sugar or powdered milk. ST2 is between 200 and 300 KST. And then one of the examples that you can get on that one is it's cellulose or good floor dust. And currently there have been some incidents in the United States and Canada as well regarding on these factories having flash fires due to wood floor dust generation under their operations. So that's the reason why it's very important to get this value. And also it's very important for those companies to know if this type of dust that they are generating they are combustible or not. So they need to go to the no-go test, or the other name that is well known, it's the screening test. So and they have the S33 classification. It's KST about 300. So you have aluminum, magnesium. Most of the metallic powders are under ST3. So that's another parameter that is important to get, and it's not for classification. It's for to have a better understanding how the powder or the dust it's gonna behave, and how you're gonna design your process as well. Is the minimum ignition energy. And the minimum ignition energy is, predicts the easy and likelihood of ignition of a dispersed cloud. The minimum ignition energy test is going to determine the lowest spark energy capable of igniting a sample when dispersed in the form of dust cloud. So, and then like I said, we used to also it's used to know and have a better understanding on the vulnerability of the powders of the dust to electrostatic. So now the NFPA 77, that is your electrostatic control program standard, come in place to because now you have the source of ignition on this type of powder is going to be the static. So how you're going to control the static, how you're going to ground your equipment, how you're going to control when you empty some supersat sacks or to your mixer tanks, for example, you do that, how you're going to control that. So that's very important to have the minimum ignition energy dust. And you see the ST3s, you see the classification, the ST3s as well, they have the lowest minimum ignition energy. When you have for example, less than 10 or less than 3, that means that the dust that you are generating from that process of the powder that you have as a raw material is very explosive. It's very combustible. It's not it's not a explosive like dynamite. No, this is very combustible because doesn't need too much energy in contact with air to generate a deflagration. That's the right term to use. And also the same parameter for now is as a dust layer. It's another one that is important to get. The values are gonna differ a little bit, and it's determined by placing a dust layer sample on a ground metal plate and approaching to the surface of the sample from above using an spherical electrode. So now, and this is very important, especially when you're gonna determine your cleaning program on the of the room, because that's gonna tell you in a layer of dust that you have. So what's gonna be the minimum ignition energy to create a deflagration? So that's very important to get as well. And then also the NFPA 654 established how much dust you are allowed to have That is, I won't talk about that right now in more detail. I'm gonna do it in the future videos because housekeeping is very important, and then we need to follow that part of the standard as well. But that value is gonna help you to understand better the vulnerability of the dust in a layer, and how vulnerable your installations can be if you don't implement or develop a housekeeping program to keep your area free of dust. And then you have another parameter that is the minimum ignition temperature dust cloud. And what it is, it's the minimum ignition temperature test determine the lowest surface temperature capable of igniting a powder or dust dispersed in a form of dust cloud. And this is an important factor to evaluate because it's gonna give you an idea of the ignition sensitivity of the powder or the dust, and it's relevant to defining the maximum operating temperature of the process for or the of how you're gonna see and how type of electrical and mechanical devices, motors you can have, or what's the maximum temperature of these motors or electrical devices they can reach as a maximum to avoid any deflagration. It's because you have dust in the process, or is generating during the process, or is a part of the raw material. That's the reason it's very important. So sometimes, and actually NFPA is very clear on in these, on especially 654 or other standards. So when you have this type of materials, the motor can reach more than 150, etc. So those type of Fahrenheit, for example, those type of elements you're gonna have. So the same factory mutual, they have they have the data sheets as well regarding on these processes. So the one is the minimum ignition temperature on the dust cloud. So another parameter is the minimum ignition temperature dust layer. So this is gonna help us to determine the lower surface temperature capable of igniting a powder or dust when it's a form of a 5 millimeters or 12.7 millimeters. Other that may be used a layer. So it's when what's gonna happen when when you have the a dust or powder sitting on your equipment, such as motor pumps, and these pumps, they are reaching a certain temperature during the operation. So that's the reason why it's very well to know this temperature, because if the pump or motor are reaching more than they are reaching the temperature higher than the minimum ignition temperature on the combustible on the dust layer form, so you can have some deflagrations as well. So that's the reason why it's very important. So another parameter that is so critical is a minimum explosive concentration. That is it's the smallest concentration of the material in the air that can give rise to a flame, or can produce a deflagration up to the ignition when on the form of a dust cloud. And that's one of the critical parameters, especially when you are in the pharmaceutical and the chemical industry, and you are empty these powders on the mixing tank, or when you generate dust due to your operation. So, and that is going to help you to design your process. This parameter is going to help you, and that's one of the critical ones. Like I said, it's very critical, especially in those type of industries, food, pharmaceutical, and chemical industries, because you have these powders as a raw material. So now you need to use these parameters to know what you're gonna do in terms of deflagration prevention. Another parameter that is critical is the limiting oxygen concentration, known as a LOC, and that's going to help you for the, if I recall, NFPA 69, because what's this value? It's the minimum concentration of oxygen capable of supporting combustion. So I'm gonna give you an example. Some of the ST2s or the ST1s like powder mill sugar. So the LOC is around 12%. So that means you're above 12% of oxygen concentration on the tank or the mixing tank. So now you're gonna have a potential. You have the chances, the likelihood to have a deflagration inside of that tank it's gonna be higher. So NFPA 69 requires this value to design how you're gonna how you're gonna inert. You're gonna make the atmosphere inert inside of that tank, and you need that value for sure. And also can define you what type of gas you're gonna use, nitrogen or other inert gas that noble gas that can go inside. Sometimes they use argon. Depends of the process that you have. The most common the most common one it's nitrogen. But I'm seeing a process that they use carbon dioxide depending of the especially in the chemical industry, because the carbon dioxide it's way more friendly, it's friendlier than much more friendlier than the nitrogen. So it depends, but it for sure you need this value to design that make the atmosphere inert. Another one is the auto ignition temperature. It's is to assess, right? It's to assess the lowest temperature at which the dust class will auto ignite when exposed to hot air. So there are many also there are many processes that you use hot air. So you control everything, and and now he can auto ignite as well because you are reaching that auto ignition temperature. So to conclude this video about uh, parameters of combustible dust and how we need to how we can classify them, you don't need to perform of the test to get all the parameters. So depending on what type of process you have, maybe you need to get KST for sure to know what type of dust you have, and that's gonna define you how you're gonna design other elements of your process, such as um, dust collectors and explosion-proof venting panels, etc. Or you need LOC to the maximum concentration of oxygen you can get inside. You don't need to go above of that to prevent a deflagration. So depending what process you have, it's the parameters you need to get, because it's very expensive to get these parameters actually, but it's necessary to get them to prevent a deflagration. And the type of incidents that currently we are having in different industries around the United States and Canada regarding on this on combustible powder, combustible dust mainly. And so depending on the process, it's the parameters you're gonna get. If you want to know more about this topic, you can contact me at 613-464-0562. And actually on the description of the video on my YouTube channel, all the information is there. You can click to my Facebook page, to my Twitter channel as well, I'm linking, and or to my webpage, pharmachemicalsafety.com. And I'm we'll be glad and happy to help you with this. Like I said, our mission is to protect people's lives. So I think this is one that we can protect a lot of lives as well. So next time I'm gonna start making on the next videos of this series of the combustible powders. So now I'm gonna start putting real cases. I'm gonna fabricate cases that when we can use certain parameters and how we can prevent deflagrations. So, but the first two videos is to set up the basis of the combustible powders, the parameters, the classification, and how it works. And remember, the combustible dust, they are governed by the pentagon, but the same as the fire triangle, if the pentagon is not completed, so you cannot have a deflagration. Thank you very much, and see you on the next video. Have a good day. Bye.